Welcome back, everybody. Now that we've gone through the operations of addition, subtraction, and multiplication of radical expressions, it only makes sense that we would just start discussing division in this module 15. Today we're going to talk about the basic rule of division. And we learned if you take a monomial term and divide it by a monomial term, you will still get a monomial term. And we've learned that since 3rd grade. We know if we take 6 and divide it by 2, we get 3. 6 is one term, 2 is one term, we divide it, we get 3 is one term. Well, the same is true in algebra. When you divide a monomial by a monomial, your quotient is always a monomial. We also know when we divide variables, we should subtract our exponents. So we'll be using that quotient rule also. So if you look at your PowerPoint, my first example is real simple. It says 24xy divided by 2x. So we know 24xy is a monomial because it's connected by what operation? That's right, multiplication. And 2x is a monomial because it's also connected by multiplication. And as long as you're connected by multiplication, we've already discussed, then you are able to go do division because mom and dad, multiply and divide, go together. When we divide, we do the coefficient with the coefficient. So 24 divided by 2 would be 12, and the 12 would be in the numerator because that's where the bigger value is. We know x divided by x would cancel out because we know a term divided by itself is 1. And then y doesn't have anything to divide with, so y would stay in the numerator. So that's why our quotient is 12y. The same thing is true with radical expressions. When we're dividing, first of all, we will only divide a square root by a square root or a cube root by a cube root. Okay? It has to be the same index. The rule is when we divide what's on the outside of the radical symbol, we will divide with what's on the outside, the coefficients. What's inside the radical symbol, we'll divide with what's inside the radical symbol. So we'll divide the radicands. And the most important thing is to understand this. If we're dividing and our numerator and our denominator are inside a radical sign, that means our quotient will be inside that radical sign. And then when we give our final answer, remember, because we're dealing with roots, we're going to have to make sure it's in simplest form. So if we look at our PowerPoint, here's our first radical expression. Square root 48 divided by square root 3. If you look, both roots are the same index. They're both a 2, so we can go ahead and do division. If you look, your 48 and your 3 are both the radicands. They're both inside. So we just go and divide. So if we had 48 divided by 3, we know our quotient would be 16. So because our expression is square root of 48 divided by square root of 3, that means our quotient would be square root of 16. Our value would stay inside the root symbol. Now, the question is, can you leave your answer as square root of 16? Absolutely not. A square root is an operation and you have to perform it. 16 is a perfect square. So what is the square root of 16, everybody? That's right, it's 4. Therefore, the square root of 48 divided by the square root of 3 is the whole number 4. Look at our second example in our PowerPoint. Negative 4 square root of a to the 7th divided by 12 square root a. Now, again, all these concepts we've been talking about all semester are coming into play. We have the negative symbol that's sitting in the middle of the fraction bar. We've already discussed this. When you have a negative symbol in the middle of a fraction bar, it floats to the top. So that negative belongs with the 4. So when I read that expression, that's why I said negative 4. Okay, if you look here, we have coefficients, 4 and 12. So we would divide those first. 4 and 12 have in common the greatest common factor of 4. So 4 divided by 4 would be 1. 12 divided by 4 would be 3. So that's where we get the fraction 1/3 from. Then we have our radicands. We have a square root of a to the 7th, and we have a square root of a. So we both have the same index. Our root is index 2. It's a square root. So we're going to take our radicands and divide them. But they're variables. So the rule is when we divide variables, we subtract our exponents. So our first variable has an exponent of 7. Our second variable has understood an exponent of 1. So 7 minus 1 would be 6. So a to the 7th divided by a to the 1st would be a to the 6th. But that would still be inside the radical symbol. And because there's more a's in the numerator, that's why the square root of a to the 6th still is in the numerator. So now our expression is -1 square root a to the 6th over 3. Well, we can't leave that expression. We have to simplify. We have a square root, and a to the 6th is a perfect square because our exponent is an even number. So everybody, what is the square root of a to the 6th? That's right, it's a cubed. Now, do we really have to write -1a cubed? No, we've all discussed that. When we have a 1 as a coefficient connected by multiplication, it's not necessary to write it. It's understood to be there. So we can write this expression as -a cubed divided by 3. Or, we've discussed this, to write it as a monomial, it would be connected by multiplication. And we know dividing by 3 means I have a third. So another way to write this expression is -1/3 times a cubed. And that a cubed is in the middle of the fraction bar, not in the denominator. It's in the middle to imply it was in the numerator. Okay, so let's go to the whiteboard and try a couple of more expressions.